Welcome to The Explainer. Today, we're jumping into cloud networking. We're going to figure out how your applications get their own unique address on the internet using Amazon's Virtual Private Cloud, or VPC. So, let's start with the big question. How do applications even get an address in the cloud? It sounds simple, but it's totally fundamental. I mean, without an address, nobody, not users, not even other services, can find or talk to your app. It's basically like needing a street address for someone to send you a letter.
And here's what's so cool about doing this with AWS. You're not just handed a pre-assigned house number. No way. You actually get to be the city planner. You are designing the entire grid, right from the city limits all the way down to every single street address. And this whole idea of building a digital city, that's really the key to getting how this all clicks together.
Okay, so let's get into it. To build our city, we've got to start with the absolute basics, the plot of land and the system for all the addresses.
So first up is the Virtual Private Cloud, the VPC. Just think of this as your own private, totally isolated slice of the AWS cloud. In our city analogy, this is the plot of land you've just been given. It's got clear boundaries, and everything you decide to build inside of it, it's all yours to control.
All right, we've got our land. Now we need a way to create addresses. That's where something called CIDR comes in. It stands for Classless Inter-Domain Routing, but really it's just a slick way to define a whole range of IP addresses. So that example you see, 10.0.0.0/16, that one block gives our brand new city over 65,000 unique addresses to use. It's like the master list of every possible street address in our entire town.
And the way you plan this out is really logical. First, you pick that one big CIDR block for your whole VPC. That's the entire city. Then you just carve that up into smaller, more manageable blocks for your subnets. You can think of subnets as the individual neighborhoods inside your city. It's a really neat top-down way to keep everything organized.
Now, this next part is super important to understand. Inside our city, there are actually two different kinds of addresses, and they do completely different jobs. You can think of it like having an internal-only office phone extension versus a public phone number that anyone in the world can call.
And this lays it out perfectly. On the left, you've got private IPs. These are for talking inside your VPC, like those internal phone lines connecting all the buildings in your city. They're secure, they can't be reached from the outside internet, and they're free. Then on the right, you have public IPs. These are your city's connection to the rest of the world. They are reachable from the internet, and because they're a limited resource, they come with a cost.
And this quote from the AWS docs, it just brilliantly sums up the security you get by default. Your city's internal private address plan is never, ever broadcast to the public internet. This isolation isn't an afterthought. It's a core security feature baked right in from the start.
Okay, so this addressing system we've been talking about, IPv4, that was the original. That's what the internet was built on. But, as our digital cities grew into this massive global digital world, that system, it started to show its age. The internet had to evolve.
Right, so the internet was built on IPv4, and it worked great for a long time. But I don't think anyone really predicted just how gigantic the internet would become. Pretty soon, we started to run out of unique addresses. It's a problem called address exhaustion. We just flat out needed a bigger system.
And the scale of that problem gets really clear when you see the number. IPv4 has this hard physical limit of about 4.3 billion addresses, which sounds like a lot, but in a world with billions of people and way, way more devices, it's just not going to cut it.
And the solution? IPv6. The number of available addresses here is, it's 340 undezillion. That's a 34 with 37 zeros after it. I mean, it is a number so ridiculously huge, it's hard to even wrap your head around. Let's just say we are not going to run out of these addresses, like ever.
So what does all this mean for you when you're actually building in AWS? Well, this table breaks it down. With IPv4, if you need a static public address that never changes, you use something called an elastic IP. But with IPv6, every address is just static from the get-go. Now, to let your private resources talk out to the internet, say for software updates, IPv4 uses a NAT gateway. IPv6 does something similar but uses a more direct thing called an egress-only gateway. And finally, you can just see the difference in raw scale in the CIDR block sizes you can even use.
Okay, so you could imagine with all these addresses flying around, public, private, IPv4, IPv6, things can get super complicated, right? Especially if you're in a big company. How do you possibly keep it all straight and, more importantly, secure?
Well, the answer is a really powerful tool called Managed Prefix Lists.
The easiest way to think about a prefix list is like a contact group on your phone. Instead of trying to manage hundreds of individual phone numbers in your security rules, you just group them all into one single named list.
And this is where the magic really happens. They are a total game changer. Without them, you end up with what people call firewall rule sprawl, this tangled mess of complex rules that's a nightmare to manage and super easy to get wrong. But with a prefix list, you can replace dozens of those messy rules with just one clean, elegant rule. And get this, if you need to give a new partner access, you don't go hunting through all your firewalls, you just add their IP range to your one list and boom, every single rule that uses that list is updated instantly. It is so much simpler, way safer, and it scales like crazy.
So all of this brings us to one final big question. As you start planning and building your own digital city in the cloud, you've got a choice to make. Are you going to stick with the classic, well-understood grid of IPv4 and just manage its limitations? Or are you going to design for the future and embrace the practically infinite expansion that IPv6 offers? The whole architecture of your city really depends on that answer.